Hey there, my superior scholars. It's Miss Campbell, and today we're going to cover patterns and conjectures. So, patterns and conjectures is basically, looking at uh, different sequences of either numbers or pictures, finding a pattern, and then using that to make a prediction. That's what a conjecture is. Okay, and you don't need to know the formal definition. It's just using information that you have to make a prediction about something that would, happen in the future. Okay, so we're going to look at our first examples here. Now, guys, don't write all this down, look for a pattern and all that, okay? Let's think about what they're asking us. Okay, what are we looking for? The next two terms. So honestly, what I would write, I'd put patterns, underline it, and then I'd say next two terms, and then I would just put these numbers, okay? And then when we get to the picture one, please don't spend forever making pictures that look, you know, super wonderful. Just jot it down and move on. All right, so we have our first pattern here. It goes 3, 9, 27, 81. Okay, we have to think, how do I go from 3 to 9? Well, I could either add 6 or I could multiply, like I could take 3 and add 6 to it, or I could take 3 and multiply it by 3, right? So we can either add 6 or multiply by 3. Now, the key is that we want this to work for every other term that we're going to get. So look from going from 9 to 27. Would the add 6 work? If I do 9 plus 6, does that give me 27? No, so it's not adding 6. How about if I do 9 times 3? Does that give me 27? Yes. So we can tell going from term to term, we're going to have to multiply by 3. And let's check it out. If we do 27 times 3, 27 times 3, does that give me 81? It sure does. So we found the rule. We're going to multiply by 3. So now we need the next two terms. So we're going to take 81 and multiply it by 3. Okay, so times 3, 81 times 3. That gives us 243. And then now, to find the next term, we take 243 and we multiply it by 3. So we get 729. So the next two terms would be 243 and 729. All right, now we will look at our next pattern that we have here. We can see each time we have a circle and then a different polygon on the inside. So the first polygon, let's look at the sides, maybe, or the corners. Maybe that's the connection. Okay, inside the first one, well, if we've got 3 sides, which means we've got 3 corners. So 3 sides there, okay. Now here, how many sides of this polygon, this square? We've got 4. All right, what's the next? We've got 1, 2, 3, 4, 5 sides. So what do we think? Oh, look, every time we're going, we're adding one side to the polygon inside, right? Okay, so our next picture will have a circle. And again, these don't have to be super beautiful, all right? Just draw a picture. And this one, it has to have 6 sides. So we've got 1, 2, 3, 4, 5, 6. Okay, so there's 6 sides. Try to make that a little bit more apparent. Okay, 6 sides. Because we're doing the plus 1. Okay, so now if I have 6 sides, well, plus 1, that's going to make 7 sides. So I go here and have to add on. This is called a heptagon. It's a little weird. So 1, 2, 3, and it should be touching the edge of the circle, but there we go. 3, 4, 5, 6, 7. Okay. Again, they don't have to be beautiful. 2, 3, 4, 5, 6, 7. Okay, so there we go. I'm sure you can draw a better picture than mine. All right, next we have 45 and then it's 40. Okay, so how could we do that? Take away 5? Okay, 40 to 35. Does take away 5 work for that? Yep. Okay, so it looks like we're subtracting 5 every time. So now we have to do 30 minus 5, which would give us 25. Then we do 25 minus 5, which would give us 20. So those would be the next two terms. Okay, now our next one, I'm going to zoom out for just a second here. This one says, use inductive reasoning to make conjecture. Okay, to make a conjecture. So inductive reasoning is taking a specific example and expanding it into a general rule. Okay, and that's kind of what we've been doing already. So we're taking specific examples and then we are extending it into the future, because we look at our first thing, is just look at the circles. What conjecture can you make about the number of regions that 20 diameters form? Okay, so in my notes, I would just write down inductive reasoning to make a conjecture. And then the first, for this first example here, I would just be like, regions that 20 diameters form. That's what I would write with the question mark. Okay, so here we go. We're going to look at the number of diameters. And then the number of regions. I'm going to make a table. Okay, tables are very handy in these type of problems. So I'm going to take my keyboard off there. Okay. So the first picture, how many diameters are there? And this is n equals 1. I'm using n to count the number. Okay, so there's one diameter. How many regions? It splits it into two sections. Okay, now here the number of diameters is equal to 2. Got the vertical one, the horizontal one. Okay, there's 2 diameters. How many regions? 4. Okay, and the next one, we have 3 diameters. There's 1, 2, 3, 4, 5, 6 regions. So 3 diameters creates 6 regions. Okay, we've got enough evidence to make a pattern here. What do you do to the number of diameters to give you the number of regions? Well, we can see we multiply it by 2. Do 1 times 2, 2 times 2, 3 times 2. So the number of regions is twice the diameters. So you can say regions equals 2 times the diameters. All right, so now we want to know how many regions is 20 diameters going to form. So we just plug in the number of regions be 2 times 20. So it would be 40. All right, and I know that you guys can figure this out with having to make the whole table, but sometimes the patterns will get a little bit more complicated. So it's better to do it on an easy one and then expand that to a more difficult one. All right, now it says, what conjecture can you make about the 21st term in RWB, RWB? Explain. Okay, so let's look. We can see the pattern repeats every 3 terms, right? Okay, so the first term of a group is going to be R, second will be W, the third one will be B. And then that's going to repeat again. So every time we do 3 more terms, land on the letter B. Okay? So like R is 1, W is 2, B is 3. 1, 2, 3. And here, this is the first time we're doing that sequence. This is the second time we're doing that sequence, right? So now we can kind of think about this. Okay, 21st term. Look at these numbers here. 1, 2, or 3. Does any of those kind of work with the number 21? How about the number 3? 21 is divisible by 3, right? Be 7. So if you were to continue this on, and you repeated the sequence 7 times, you would have 21 terms, right? Because look, here this is our first term, our second term, third term, fourth term, fifth term, sixth term. So we have 6 terms already. And what are we noticing? Every third term is the letter B. And 21 is a multiple of 3. So we can conclude that the 21st term would be B. So B is the 21st term. Okay? Because every third term is the letter B. Okay? So you kind of have to look at the term number that they are giving you to look for and look at the pattern that you have and try to see if there's any like common multiplication there. Okay? So I saw, 21 is divisible by 3. So that's how I worked that out. Okay, so we have now, what conjecture can you make about the sum of the first 30 even numbers? Okay, so we'll start off, we'll make a table. Do, okay, 2 plus 4, what does that give us? 6. Okay, and let's keep track of how many numbers we're adding here. So we added 2 even numbers, and that gave us 6. All right, let's do the next one. So 2 plus 4 plus 6. Well, we already know 2 plus 4, that's 6. Plus 6, that is 12. All right, so we added 1, 2, 3 even numbers, and that gave us 12. All right. 2 plus 4 plus 6 plus 8. Now the first part is 12, so 12 plus 8 is 20. So we added 4 even numbers, and that gave us 20. Okay, let's do another one. 2 plus 4 plus 6 plus 8 plus 10. Well, we know 2 plus 4 plus 6 plus 8 is 20, plus 10, that is 30. So we added 1, 2, 3, 4, 5 even numbers, and that gave us 30. Huh. Let's look here. Maybe we see a pattern. Well, what can we do? 2 times what gives me 6? Okay, 2 times 3, right? Okay, how about for 12? 3 times what gives me 12? Times 4. 4 times what gives me 20? Times 5. Okay, 5 times what gives me 30? Times 6. So you see the pattern there? You take the number of even numbers that you're adding together, you multiply that by one more than the number of even numbers, okay, and that will give you the sum. So here, we're doing 2 times 2 plus 1, right? Because 2 plus 1 is 3. And that gave us 6. All right, we do 3. And then look at 4. 4 is 1 more than 3, so we did 3 plus 1. And that gave us 12. So if you notice here, you're taking the number of even numbers, so you're doing n, and you're multiplying that by n plus 1. And that will give you the sum of those even numbers. So now they're saying, okay, we want to do the first 30 even numbers. So we want to do 30 even numbers, and we have to multiply that by 30 plus 1, so 30 plus 1. So we're doing 30 times 31. And then when you actually multiply that, 30 times 31 would give you 930. So that is going to be the sum of the first 30 even numbers. So We looked at a pattern, like we actually tried it out, okay? Tried it out, because I surely didn't know that pattern. You have to try it out, look for relationships, and then try to make that relationship go on for any number of terms that you would have. Okay? So again, if the n thing confuses you, you don't have to worry about that. As long as you notice that, oh, I'm doing the number of even numbers and I'm multiplying it by one more than that, that's getting me my sum, that's good. Okay. Now the last example that we have, it says, use the graph on the right to make a conjecture about the number of backpacks the company will sell in May. Okay, so we have to look here. We can see it's a downward trend, all right? It's a downward trend. And we kind of look, now these are not exact. This is just an average change, okay? So from November to December, they went from 11,000 to 10,000, about 10,500. About, okay? Rough estimates here, okay? Rough estimates. Because remember, we're predicting. We're not trying to give an exact number. Okay, so then from December to January, okay, look, it was a little bit above 10,500 and then went down to a little bit above 10,000. So it went down about, again, 500 more. Okay, here, well, they took a little bit bigger jump, but in January it was roughly 10,000 and went down to about 9,500. So again, it's about 500 down. Same thing here. It's about 500 down. So it looks like they're decreasing about 500 per month. Okay, that is the overall trend. So now they want to know how many backpacks will they sell in May. Well, we have to look at the month before May. They're at about 8,500. So in May, we go down 500 more. They're going to sell about 8,000. Okay, so y'all, the key for today's lesson is just you have to look for patterns. You have to look for relationships. You've got to be analytical. All right, and that's a main tool for geometry. So just go through on today's assignment, try different things out. Try to make charts like we did in some of our examples. Okay? When you do that, you'll be able to see those patterns and you'll be able to figure out the next few terms. So that's all we have for patterns and conjectures, and I will see you guys next time.